Today we have to discuss about the problems on interference chapter. Okay, so the first problem in that a biprism is placed at a distance of 5 into 10 to the power minus 2 meter in front of narrow slit illuminated by sodium light of wavelength 5890 angstrom. So you have to craft a biprism, and this biprism we have to craft from the source S at a distance A. That distance is 5 into 10 raised to minus 2 meter, and the wavelength of this source is 5890 angstrom, and the distance between the virtual source is found to be. Okay, here two virtual sources are formed, S1 and S2. The distance between the virtual sources is G. So A, here you got 5 into 10 to the power minus 2 meter, and the distance between two virtual sources is D. And D, here you got 0.05 into 10 to the power minus 2 meter, and the wavelength of this light source is lambda equal to 5890 angstrom. And then find the width of fringes. Here you have to find the width of the fringes, and observed in an eyepiece placed at a distance of 0. Here is the eyepiece. The distance between the prism to the eyepiece is B, and they given that the place at a distance of 0.75 meter from the biprism. So they given the B. So B is the 0.75 meter. Okay, these are the given data of this problem. Okay, what they asked the fringe width. Okay, the width of the fringes observed an eyepiece. And now here you have to take the expression for fringe width. Expression for fringe width, that is, you know that beta equal to lambda d divided by d. Okay, so you have this lambda value here, and capital D value, it is the total distance from source to the screen, that is capital D. You have to take D equal to A plus B. Okay, now you have to find out the D here. D equal to A plus B. So A is 5 into 10 to the power minus 2 meter, and as well as plus B is 0.75 meter. So add this one, you got the 5.75 into 10 to the power minus 2, that is capital D. And next what you have to do, take beta equal to lambda value is 5890 angstrom. It is in angstrom, you have to convert it into meter. So at that time 5890 into 10 to the power minus 10 meter, and you have to shift the 3 points here. At that time 5.89 into 10 to the power minus 7 meter, and you have to put the lambda value here, 5.89 into 10 to the power minus 7 meter, and D value is 5.75 into 10 to the power minus 2, and divided by D value is D value 0.05 into 10 to the power minus 2 meter. This is D value, and you have to substitute this value. I think you got nearly 6.77 into 10 to the power minus 5 meter. Okay, this is the fringe width of the fringes we got here. Okay, this is the problem. And next problem is here. In a Newton's ring experiment, the diameter of the 15th ring was found to be 0.620 into 10 to the power minus 2 meter, and that of the 5th ring was 0.420 into 10 to the power minus 2 meter. If the radius of the plano convex lens is 1.2 meter, calculate the wavelength of light used. Okay, using the Newton's ring experiment, you have to find out the wavelength of light used. Okay, first here you have to take they given the two rings. Okay, so first ring is D15 and it's having a diameter D15. Okay, diameter of the 15th ring 0.620 into 10 to the power minus 2 meter. And next one they given the D5th ring is having a diameter 0.420 into 10 to the power minus 2 meter. And which one having the highest, which one having the last maximum value, you have to take it as m2 is equal to 15, and this one is the lesser number ring, you have to take it as m1, that is 5th. It is having a 5th ring, so m2 equal to m1 equal to, and what they given the radius of the plano convex lenses, so you have to take it as r equal to 1.2 meter. And wavelength of monochromatic light, you have to find out the lambda equal to what it is. And here you have to take the expression for the wavelength is so wavelength for the Newton's ring, you have to take it at lambda equal to dm2 square minus dm1 square divided by m2 minus m1 into 1 divided by 4r. Okay, this is the formula for the expression for wavelength. So here we got the given dm2 here and dm1 here, and 0.620 into 10 to the power minus 2 square minus 0.420 into 10 to the power minus 2 square, first and second ring, and divided by m2 minus m1. m2 is 15, m1 minus m1 is 5, and into 1 divided by 4 as it is. R here we got 1.2, 1 divided by 4 into 1.2. And next you have to simplify this, you have to square this term and this term, you'll get a 0.208 into 10 to the power minus 4 divided by here 15 minus 5, you got the 10 into 4 into 1.2, that one you have to got the 48. So make it divided by 2, you got the 0.00433 into 10 to the power minus 4. So you have to take 4 points on this side, at that time 3 points on this side, at that time you got the 4.33 into 10 to the power minus 7 meter. So again you have to send the 3 point, at that time it is 10 raised to minus 10, means 10 raised to minus 10, again you have to send the 3 points. So 433 into 10 to the minus 10 andre you have to take it as angstrom. This is the wavelength of that monochromatic source. Okay, similar problems are given in the textbook. You have to solve, and if you got any doubts, you have to ask me. Okay.